The relative wage is determined by the allocation of production between the cloth and food. So what will happen if we produce more cloth and less food? So we can see if we produce more cloth, and as we talked about earlier here, the production of cloth is labor intensive. It means that they always use more labor uh, in when they produce cloth. They will use more labor relative to capital compared to production of food. So it means when we produce more C, we will use more labor. So the aggregate relative demand for labor will increase. And when the aggregate aggregate relative demand for labor increase, the relative price of labor will increase. And when the relative price for the labor to capital increase, the company tends to substitute the capital for the labor, because when the wage rate increase, they want to reduce the cost by substitute their capital for the labor, so that the relative demand of labor to capital for the cloth production will decrease. And also the relative demand for labor to capital in food production also decrease. As we can see here, this figure also shows the relationship between the relative production and the relative factor price. So we can see that if the relative quantity of the cloth to the food increase, the relative price of labor to capital also increase. So they have they have positive relationship. We can explain that when the uh, quantity of production of cloth increase, since the so the demand for labor will increase. So we have the relative demand of labor in uh, of labor to the capital in cloth production increase, because uh, as I told you before, that the cloth production is the labor incentives, so they use more labor uh, compared to the capital than the food production sector. That's why when the demand for the labor in cloth production sector increase, the price, uh, the wage rate for the labor will increase. So the relative price of the labor to the capital increase. Okay. And here is the relationship between relative factor price. Here, relative factor price. Here is the relative price of labor to the capital, and the relative good price of cloth and of cloth to food. So we can see here the first point we have is the relative price of labor to capital in food production, and the second point we have here is the relative price of labor to capital in cloth production sector. And we can, if the relative price of cloth to food is less than the P1 here, it means that the company will the economy specialize in producing food, and P1 here will equal to uh, the wage rate of producing food times the labor they use to produce food plus the rental cost for the capital in producing food times the amount the capital they use to produce 1 calorie of food. And here they will specialize in food. In this area, when the relative price of cloth to food is less than P2 and larger than P1, so they will produce both food and cloth. And P2 here is equal to the wage rate in cloth production sector times the labor used to produce 1 meter of cloth plus the rental cost for cloth for the capital times the capital they use to produce 1 meter of cloth. Okay, see. So if the relative when the relative price of cloth to food is larger than the P2, they will specialize in cloth. And here is both food and cloth. Okay, let me give you an example. A martini is produced with gin and vermouth, and a regular martini is produced with 2 parts gin for 1 part vermouth, and a dry martini is produced with 5 parts gin for 1 part vermouth. So here we have two products. The first one is regular martini and the second one is dry martini. And we have the price for a regular martini is PM and a dry martini is PD, and that the price is fixed. And we also have given supply for both gin is G and vermouth is V. So the question is, what is the output of regular and dry martinis? And the second one is graph the martinis ppf. So let's see, we can calculate the PM, the price of martini. The regular one is equal to okay, let me show you. So we have two parts of chin. Will plus one part of the mouth will equal to one regular machine, right? So it means we need we need one third of the mouth and two sorry, one third of the mouth and 2/3, two-thirds of the chin to make the regular Vatini. So that's why the price of regular martini is equal to 1 divided by 3. That is equal to the ALV. One third times the wage of producing vermouth, and two-thirds times the wage of producing gin. Okay, this one is ALG. So here we don't separate like capital and labor anymore, but here we replace it two different factor that is vermouth and gin. And the same, we also can calculate the price of our try martini, that is equal to 1/6 times the weight for vermouth and 5/6 times the weight for the gin. So one here, why here we have 1/6 and 5/6, and here we see the tri martini is produced with 5 parts of gin and 1 part of vermouth. So also the same that we have 5 gin with 1 vermouth will equal to 1 try. So that's why we can have uh, for the for vermouth we need 1/6 of the label, and uh, gin will take 5/6 to make a dry martini. And from here we can calculate the weight of vermouth and weight of gin. You can do the calculation by yourself. If you cannot do it, just ask me in the Zoom meeting or email me. However, you have to do it by yourself first, okay? Then we can have the weight for vermouth is equal to 5 ppm minus 4 pt, and the weight of our gin is equal to 2 pt minus pm. So through this formula, we can see the relationship between the price of the products, regular martini and the dry martini, with the weight of the material vermouth and gin. So here we see if the price of dry martini increase, the weight for vermouth will decrease. However, the weight for gin will increase. Okay, and let's see the second one. Uh, we have to construct the PPF. So do you still remember the constraint? So here we have the fixed supply for vermouth and gin is V and G, right? So this one is the fixed supply for them in economy. And here we have the amount, the labels, the resource we need to produce qm. Qm is the quantity of our regular martini, and qd is the quantity of martini. So we have uh, 1 over 3 times qm plus 1 over 6 times qd equal to uh, the fixed supply for Vermouth. So the first one we have the Vermouth constraint, and the second one is the Chin constraint. So for Chin constraint, we have the total resource are they need the total Chin they need to produce QM regular martini and QD dry martini. So we have this formula, and based on to this constraint we can calculate the intersection between them. The trade quantity is qm is equal to 5v minus g, and qd is equal to 2g minus 4v. So that is to this point. The intersection of the Vermouth constraint, this one is Vermouth constraint, and Chin constraint. So here we have 1 over 3 1 over 3 qm plus 1 over 6 qd is equal to v, right? So when they use order Vermouth to produce the tri martini, the total amount they have is qd will equal to 6v, right? And if they use order Vermouth to produce the regular, we will have the amount is qm is equal to 3v. So we can draw this line. qm is 3v and qd is 6v. And the same for the Chin constraint, you can calculate to this point 3 over 2g and 6 over 5g's. Then you can draw this line. Okay. Okay, in case some students are still don't understand this part, so I will write it down. That is 3 over the constraint for the Chin, 3 over 2 over 3 qm plus 5 over 6 qd is equal to the fixed supply for Chin, right? So the first case we will consider if they use all the Chin to produce the dry one. The maximum quantity we can produce the dry martini is 6 over 5g, right? That's okay. This one will be equal to 0. And the second one, when this one is equal to 0, they focus all the resource Chin to produce the regular. So the total regular you have is 3 over 2g. So that's why you have, sorry, to this point, and you have the light. And we see the intersection between them here. And this line, the green line I'm drawing, that one is the ppf of martini. Okay, that is quite easy. So far we already learned about Ricardian model and also Offline model. So please uh, understand what is the difference from them and how to apply those model in the real life. Thank you.